Welcome back to the shop. My name is George and I'm coming to you from Chelsea, Quebec. Now, every so often, either my wife or I will have a suggestion for an activity that's out of our ordinary repertoire. It might be something like, hey, let's try turning the thermostat down to 15 for a week and see how we survive it. Or let's rent an RV, which we don't do, and go away for a couple of weeks on the road. So whenever we have one of these ideas where it could either be a life-changing experience or maybe a complete disaster, when one of us has this kind of an idea, we always start by saying, don't say no right away. And that, as you saw, is the title to this video. Don't say no right away. The thing that you're not saying no to right away is 3D printing. I'm thinking of making this video an introduction to 3D printing from the perspective of a woodworker. But I'd also like to hear or read your reaction to it by saying something in the comments. Is 3D printing something that you'd like to learn more about? Is it something that you would like to see as a regular installment in these videos? Should it be forbidden altogether? I don't know. So this video is going to be an introduction from the perspective of a woodworker to 3D printing. And then if the reaction to it is really negative, I won't say anything more about it. And alternatively, if the reaction's strongly positive, well, I'll toss in a little bit from time to time. So this is my tracked camera vehicle. I've already tested and refined the operation of it. And now what I want to do is tuck all of the components into the interior. So I've already screwed the electronics here to the top of the unit, and the voltage regulator is sitting off here to the side. It's been hot melted into place. And what I want to do now is find a place for the battery pack. So the battery pack is going to sit on the bottom down here, but as you can see, it's quite loose right now. So what I'm going to do is create a platform that'll sit here at the bottom, and then the battery pack can just sit on top of the platform. The platform could quite readily be made out of say 1/8 inch plywood. That would be a really easy job for a woodworker. But I wanted to give that task over to 3D printing. So let's see how that fares. So the width of the platform is going to match the interior width of the carrier, and its length is going to be about 10 millimeters longer than the length of the battery pack. Now, it'd be really straightforward to make a slab with those dimensions, but what I'm going to do is also ask for a recession in the middle, a little bit like a sunken living room, so that the battery pack can just nestle itself into place. So here's the printer laying down a floor that's going to support a battery compartment. The floor is going to be in the shape of a tray. It's already laid down the bottom layer, and the grid pattern that you see is just 10% fill. So the floor is going to look like a solid piece, but the interior is made up of this grid work so that the thing doesn't have to fill the entire space with filament. I'll show you this thing's progress a little bit later on with another shot. So the printer has now finished making the infill portion of the floor, and it's now covering the bottom with well, a floor, if you will. It's laying in the subfloor. So this is now the recessed part of the floor, and then along the perimeter we're going to build up another 4 millimeters of wall. So we're a little farther along, and we can see the field being developed a little bit more. So field or floor, I'm calling it by different things. Anyhow, the upper surface into which the battery compartment will be nestled. So that's moving along, and then on the perimeter you still have the fill being created. So on that perimeter there's going to be some walls built up, so the floor isn't being finished there. It'll continue to rise higher and then get filled at the top of the wall, not at the floor. I can see there's already a bit of a flaw in this creation. If you look at the edge of the floor, you can see that it's notched. So it finishes right to the proper place when the crisscross is underneath, but where there's openings in the crisscrossing, the filament isn't being supported and it's falling through. I think that was my mistake in not asking for support to be created. You see, the software that figures out how this machine should be instructed, that software figures out what parts need to be supported because they're hanging over empty space, and what parts don't need the support. And I had checked off don't bother with the supports on this build. None of that matters in this case because this floor is destined to be at the bottom of the interior of a little something. In other words, it won't be seen at all. The flaw will be covered up. Still, the lesson is there, and now I know better what to anticipate if I make something similar down the line. So it's farther along still. It's clearly no longer adding anything to the floor. That's all done. And now you can see that it's building up the walls along the perimeter. Eventually they'll be capped off and the platform will be finished. Here it is now doing the final touches on the build. It's lacing back and forth over top of the wall, so it's putting the cap on a few of these layers and it'll be all done. So here it is, all done. The battery pack slips right into the recession, so that's going to keep it firmly in place. Now I've added a couple of notches here, and these accommodate some screw heads that are already on the interior. That'll have the effect of locking it in. It wasn't planned, but it was something I had to add. I could have added these in software and had them created automatically if I'd thought of it. Of course, it was just as easy to add them afterwards with a hand file. So the platform will slip in here like this. There, it just nestled itself over the screw heads, and the battery pack will follow. There, I think that's in now. So, job done. So, do you really need a 3D printer to make something like this? Of course not. I could have made this in a fraction of the time with just a few pieces of scrap wood. But take a look at these. I'm going to bring you in for a closer shot. So these are couplers that go between a motor and a hub. And I 3D printed them. Didn't take very long. This was about a 17-minute print. The thing that makes them special is that they're custom fitted to this particular arrangement. So at one end I have a tube, basically, that tightly fits over the hub. At the other end, the motors that I bought came with cylindrical shafts, but these shafts have been flattened on opposite sides. So the business end of this shaft actually has a rectangular shape more than it does have a cylindrical shape. So I arranged the printing to give me about a millimeter of cylinder that'll cover over this end here, right close to the motor body. Then a rectangular portion that fills in the bits of the cylinder that are missing, and then it's capped with a solid fill, and then it goes on from that with an open tube to fit over the hub. At the same time, I asked the software to put in a cylindrical hole down here at the end, and then afterwards I hand tapped some threading with some 440 threads. So approximately something like a 2 or 3 millimeter screw. So this shape mates perfectly with the shape of the shaft, and it's not something I could have found in an off-the-shelf part. Like that. It's really solid. So there it is. Everything's neatly tucked away, and it looks like everything still works on it. I've mounted the camera since the last time you saw this, and you can see that the camera up and down position works perfectly. So this is great. I can't wait to show this off at the next meeting of the Ottawa Woodworkers Association. Just to wrap things up on 3D printing, a couple of big points to mention. So getting started will set you back, let's say, between $500 and $1,500 Canadian. As a woodworker, you'll want to get a heated bed. Don't get the kind that doesn't heat its bed. This is because for some things that you'll want to create, you'll want to use nylon, and nylon needs a heated bed in order to be 3D printed. The things that you need by way of software are freely available. Now I'm guessing that as a woodworker you don't want to make little plastic models of Yoda or Batman wings, but rather you'll want to design and build contraptions suited to specific projects. So as such, you're going to need a computer-aided design, a CAD program of some sort. SketchUp can be used. There are others that work a little bit better for 3D printing. So that's one kind of software that you need to create the object that you want to print. And the second thing that you need is called a slicer. Again, this is software. And what the slicers do is they take the file that was created with a computer-aided design program, and they look at it section by section and write the instructions that the 3D printer will understand. So you use the CAD program to create your object, and you use the slicer basically as a driver to pass it over to the 3D printer. So that's pretty well it for what you need to get started. Now I'm curious about whether you guys want to hear any more about 3D printing. So if there is an appetite for it, let me know in the comments, or if you think it's silly to even talk about this stuff, let me know that as well. If you have any specific questions or general questions about anything, put them in the comments. If the question is easily answered in writing, I'll answer it back in a comment. If it's something that requires a more elaborate explanation, then I'll create a video about it and answer it in video format. So until then, bye from me, and don't forget, indulge your passion, but share it.